Hello everyone, this is Bradley. Today this is another geometry nodes modeling practice in which we're going to make a procedural aperture. Just for knowledge that very long time ago I actually made a procedural aperture using animation nodes, and a year later, actually it was last year, like December 2020, I discovered basically a simpler method. And I used to think that I'm going to present that, but later I realized, geometry nodes comes out, no one cares about animation nodes anymore. So let's do this in geometry nodes. So here we're in 3.0, and maybe I've said earlier in the past that basically if you're trying to so every time if the title contains the practice, it's never a real tutorial. Even if I said it's a tutorial, it's simply basically like a voiced working experience from whatever. So which also means I might fail, there might be things that I stuck or whatever, but this is real life experience. Anyway, I'm going to start with a single vertex. I'm going to explain why later. So basically the biggest issue of the geometry node. So let's duplicate the vertices because I need two objects. One I'm going to talk about the unit, the other is the compose. And I'm going to add a geometry modifier. The biggest issue of the geometry modifier is currently, if you're trying to point an instance, you cannot instance yourself because it will cause a infinite loop. I don't want to explain things which are in the technical background, other things. Imagine by yourself why the pointing instance to instance itself will be a problem. It can also not instance a geometry node tree. Maybe it will be implemented in the future. The biggest issue, another biggest issue is if you're trying to make a circle that you are defining the, why did you change the color? Jesus Christ. Okay, so if you make a circle mesh, it's basically a full circle. You create a full circle. It's not like animation node that you can decide the arc of this circle. When you get a circle, regardless of the vertices, you get a full circle, which is very bad actually. But in this case, the biggest issue when you're creating a blade is that you do not know the amount of blade. I may have a 5 amount of blade. I may have 5 blades, 6 blades, 13 blades, whatever blades of my camera or aperture is. So in that case, the arc for each blade will be different. So the smaller amount of blades, larger the arc is. In this case, I cannot use a full circle, and I need to be able to change all this kind of stuff. So here I created a single vertices, and I'm going to use a screw modifier. Screw modifier is actually very powerful. Just take a look with what it happens. So if I take the screw modifier with a single vertices, it will actually extend it to that place, and the step view is 16, which means this line will be cut for 16 times. We will see the effect later. So I'm going to select this modifier and shift this, duplicate another modifier. Nothing happens, actually. But if I change the axis, something weird happens. But if you change, just try with a number. I don't think I need a screw, but I need to determine the angle. So now if I rotate on Z, this is how it works. Very cool. So now actually can change this angle. Okay. So this is the unit of our aperture. Okay. This is the unit of our aperture. Next step is within our compose we have the geometry nodes modifier, right? And I'm going to create a circle. So this is the moment that you can really create a circle. Take a circle, maybe just a small number, starting with a simple example. Otherwise, our life will suffer too much with this entire whole thing. Take the vertices back, and I'm going to take the radius back. So within the group, I'm going to determine the radius. It says infinity. It's okay, but probably do not need the infinity. Let's just take a 2 for the moment. Okay, default as 1, which is okay. So we have 6 blades. I'm going to point instance of blades to the place. Select all blades. Everything has not been aligned. In such kind of case, when we are working with this, we always use the align rotation to vector. We are working with a circle, so it does not contain two normal. So let's take a attribute and it does not have a normal option. So let's just take position. Basically, if the position goes in that way, it will just be aligned that way. Let's take the yes, because we're extending y. And then if I decrease the radius until the 0, so at 0 everything will disappear because the position is not looking at any directions. So it is basically does not know where to look at. So we need to take a clamp. We take a clamp, minimum, maximum. Let me think. Oh, actually, I do not want to use a clamp because if you clamp two sides, which is bad. So we are going to use a one-side clamp, which is called a minimum and the maximum. Basically, no value will be lower than this maximum. So in this case, it's a one-way clamp. It does not hold your upper limits, but your lower limit must be larger or equal to this B number. So this is a one-way clamp instead of clamp. So if I decrease this radius to 0, which looks like a 0, but it's not really a 0. So very nice. It actually works pretty well. You can also type the small enough number anyway, so that you really do not see any issue. One biggest issue that we need to realize is we need to, as I said previously, if I need 6 blades with 6 vertices, I need to be able to determine this angle. Actually, I forgot to show one thing, that we have a lot of. This is a highly subdivided arc, but I don't need these amounts because I think a blade it just look like a blade. I think this is good enough. Another thing is this is a step view. So you need to know what's the parameter really define the subdivision in this case. Okay, so we're going to use the vertices number to control this angle. What we do is basically I'm going to copy the driver, right click, copy as a new driver, and I'm going to paste the driver. It will give you wrong result. It will give you very wrong results. So we edit the driver. I hate the driver because I never usually use driver a lot. I use animation nodes for all these kind of things, which is much easier because I hate access all this kind of driver editor. It's a little bit like when you are working with attributes because you are actually really working with attributes. You're working with parameter scripting, whatever. So I don't like input file. You can type a concrete name so that you know what you're working with. And the more important thing when you're working with driver, always switch that script description because I otherwise think it's useless, pointless. And I need a vertices. So I determine the vertices. I need a 360 degree divided by vertices, and it will cause errors. It's very wrong because everything goes to 3000, whatever. The reason is that if you realize previously we were discussing the 6 vertices, but the number goes to 344, I think. The reason is whatever you type here is in radians, and the 2 times pi is 360 degrees. So if we want 360 degree, 2 times pi, and we get everything right. Forget our units, then we have everything correct. And you can increase the radius. Everything is just oh, it looks nice. Something is wrong, however. I'm not really sure. Looks kind of nice. So the whole point is, if I'm increasing the vertices, it looks pretty well. Did we actually finish this aperture? Doesn't look right. It does not really look right, because I think the aperture will actually rotate by itself. Basically, the aperture will all this kind of edge should always form a circle instead of being broken apart like whatever fractured pieces. So this is the part that we also need to deal with. Okay. So here, what we're trying to do is when we try to align the rotations, we always automatically create a rotation attribute. So anyway, I'm just going to use the point rotate. The rotation is basically working this, and if we rotate in this way, oh, it looks so nice, awesome, fantastic. This is exactly what we want, and I think this is aperture. So basically, but if we try to reduce the radius, oh, it works. Oh, everything. Oh, this is so amazing. Oh, this is so amazing. I like this so much. Actually, we already get our answer. But there's something wrong. If I decrease this angle has to be changed. I don't actually know the rule of I don't actually know the rules over there. So how can I actually determine the angle with these vertices? I have no idea. Can I actually rotate the points? It does not really change it. I actually do not know the automatic way to rotate these things later. Wait. I really don't know. What's the rules between this entire thing? It does not seems a issue if I do not care about this. I'm not sure, I'm getting confused. Probably I will just leave it not solved, because I almost forgot how I actually deal with animation modes. There is essentially ways, but I don't think it's very important to take care of this in this case. Yes, I think I will just leave it as it is for the moment, because it looks cool anyway. So this is the reason I'm using the 3.0 is because I would like to rotate it. I don't want to have a dead blade. Although I think it's very okay that if you want to use this dead blades, I think it does not really matter. So basically, if you think that blade is fine, then it's okay. But I think the center, I would like to have the center part to rotate to the other places. This is my intention. And this is also a tricky part, because you need to decide which is the part that you deform. You can deform everything after the instance, but in that case the evaluation will be very difficult. So I would do everything on the original mesh. So let's create a geometry nodes modifier. So this is the second node tree. So let's just call the unit manipulation. Just a unit manipulation. It does not really matter with the name. And just name this as compose. Okay. What we do is we have these. If we go to the wireframe, and we have this amount of vertices, and closer to the center, it will be affected more. It's basically something we've discussed in our first modeling practice, in which we're creating a keycap, and there was an indentations based on from the center. So this is what we created last time, the keycap indentation. Okay, so this part, basically the same principle. So just to make kind of made it very quick. I'm going to take the length. I'm going to take the d as distance, d distance. Actually, I'm going to take the position. I forgot. So take the position to evaluate, and attributes math, attribute color ramp, and attributes. Okay, you can take an attribute math. It does not really matter. Take the d float. I'm going to take the multiply. Duplicate the same things. Multiply. Type 1. Type 1's d and d r d. Okay, and I'm going to reverse this entire whole thing. Because I basically explained everything in our first modeling practice, I don't really would like to repeat the same things, but I will just wait a second. To really visualize what we have done, we're going to use the, so first let's, the easiest way if you try to visualize is to use the point translate, because we're doing deformation anyway. So use the attribute and type D, everything will just becomes, oh, it flies away, because the D has been written as DDD. But we only want the D2 as I only want the D2 effect at how should I say, the effect on the z-axis. So take the DD. This is the elevation. So talking about the vector, the math that we have. So if we increase the mass or decrease the mass, it's increasing the size. And decrease the second attribute mass. So basically what we have to do in this color ramp is basically we reverse these entire attributes. You can also use the attribute map range. Basically to do the same things. So whichever way you want. But just to know that you can change the interpolation methods while the map range is very dead. So this is kind of nice. Let's change that to ease so that we have a ease. I don't know, but I don't think I actually did everything wrong, because I don't want elevation. Elevation is something that I want, but at this moment the most important thing is not elevation that I'm looking for. Okay, I'm going to delete this elevation for this moment, but I would like to rotate this entire whole thing. So we're going to use the attribute vector rotate. This is a new node. Actually, this is my first time to look at this node. I also need to familiar with this within this noding, but I think it's kind of very straightforward. We have the center. Okay, we define the center at here. Nice. Vector is the position because we want to rotate the position. Okay, and the axis is basically the axis XYZ, we know. So in this case, we rotate angles and we need to write whatever stuff. We need to write position. Okay, so now we actually rotate. This is simple. It's so simple. But we rotate everything as a whole. So why not use the transform node, right? The reason we need to use an attribute is because we would like to rotate each point differently. So the outer point should be rotated more. Is that correct? Yeah, I guess so. Which means we previously reversed this color ramp, which is not really necessary. So I think I will just rename that as a DI. And I will take everything as a DI and DI. But I also need to duplicate this as a D and D, so that we have two attributes to basically work with. One is D, one is inverted D, which is called a D inverted. I think in this case we are trying to take the angle, because angle can receive the attribute. I'm going to take the D, then immediately you can see the effect. Yes, this is so nice. This is why I need this. And we can use this to determine the angle of rotation. So now we actually look back to whatever we have. Then we have a very interesting aperture mesh being generated. It looks like a sun actually. Very nice, very nice. So now we have the rotations, but I would like to take these kind of rotations associated with the radius, because actually I don't need to. I realize that I don't need to, but I don't know. This becomes a tricky question. Okay, I realize the plan. I think this is what I will do. So if I have this radius, and I'm going to take a map range. So we know the maximum will be 2 because we defined it earlier. And then I'm going to define the degrees at this place. So the maximum, whatever degrees. but later it will be another degree. So take a map, take a combine XYZ. Take the Z vector to place. So now it does not have anything. So basically, if I have zeros, it's basically rotated zeros. But once if I have this place, then it will maximum to another angle. So I suppose this is a linear function. Actually, it is not. Oh, this is so awkward. A complete failure. Now actually start not now. Hey, how am I supposed to know? Anyway, another thing, so let's forget about this. Forget about what we just said. Next thing that we need to actually deal with is is this kind of the blades rotations. So I'm going to do the same. I'm going to copy the as new driver, just to give it a kind of trial. And I'm going to take I'm going to create an input within the group, but we cannot directly do so. So the way we're trying to do actually, let me think a better way, because this is the determine the rotations, right? So in this case, what we're going to do is to take this back to place, and so I'm creating a map range. Okay, so within this B, I'm going to paste the drivers. So this is basically the radius we have. So in this, we still know the map range is range from 2, and then we're going to try to rotate this. So here, let's just try to see what we can actually get. So initially it has nothing, but later it actually rotate. Oh, this is amazing. This is exactly what we want, or what I want. Looks kind of cool, very cool actually. I really like this. And we need to determine this angle a little bit. So in this case, I'll probably just combine XYZ and plug this angle to the place so that we can actually determine these angles. Yeah, I think this is how it works. I'm not sure how Aperture really works in this case, but we get something. The issue when we are trying to use this kind of strategy, and this is the issue that I realized in animation nodes, is that we have this kind of, once we have done this, the blades actually start to overlap to each other. There is a Z fighting. I really like this kind of design, but the Z fighting is obviously not what we want. Everything becomes even worse if you're trying to add a solidify modifier in the futures to do whatever stuff. But in this case, how to avoid all this kind of problem is that I'm going to elevate this kind of blade at the center. And basically, this is why we kept the previous inverted D, because here I think I'm just going to, so here let's just take the attribute combine attribute D's, and I'm going to increase the D. Where's my DI? Oh yes, I need to call that DI. And immediately we get our effect. Oh, this looks so nice. You just need to tweak a little bit about these whatever values, and I think we need to link everything within to our radius. So let's just go to the beginning. Let's rename this B as radius scapegoat, radius representative. Just a radius. Actually, the name does not really matter if you know what it does mean. Okay, fine. We have this radius, then we do this. then what we do is I hate this the linearity of this entire attribute system. Actually, Houdini is also kind of very linear, in my opinion. But the good part of Houdini is you can type a script within, but we do not have a script node within geometry nodes yet. So once we do this, we're going to use the map range to do similar kind of things. So just to make everything easy, I'm just taking map range to the place, and then I'm going to define the amplitude. So the whole point is that the whole point is that once I'm using the radius, everything is just a flat. Okay, and if I'm trying to use this radius, then they will goes up. Then this is how it looks. But it goes too up, doesn't it? This is something that we need to control with the color ramp. Oh, this is awkward now, because we do not have the color ramp. Oh, we have. What? Oh God. We have the color ramp, and we can type the color into. Okay, this is nice. I didn't know this. The way we're going to solve is we're going to put that. The issue of the color ramp that I hate in most of the time is that you're using this white instead of a single value, and it will probably change the value as well. I don't know how to explain, but I'm going to take that to black. I hope this will work. Does it? Oh, yes, it does work. Everything goes down. So we need to change these parameters. Take the. Okay, I think this is it. So here we need to change the scale. The thing I don't like geometry nodes is that you have to go back and forth in different objects so that you can change the value for different modifier. But I think this is it. Oh yes, this is almost it. And up to this moment, I start to realize probably at maximum at 2 is not a very good idea, because I feel like the hole is too large. And we're having parameters scattered around in different places, which is causing kind of a problem, because I realize I don't like this. But anyway, I think you can tweak these parameters by yourself, like what's the maximum of these angles, and take type in 0.1 and take this rotation to the place, and you can always arrange all these kind of things within that, rename that or whatever. And within the compose, I think I don't think we need to change anything in the compose. So I think that this is it. So everything will just be further managed by you. Like I would like to take the maximum. This the from maximum is very important, the radius maximum. Because what if I would like to make this maximum hole smaller? So we have to take the range completely different. Well, I think this is it. So I hope you enjoy this practicing. Maybe you have a better thoughts, I don't know. But anyway, so I hope you enjoy this tutorial or whatever stuff, and I hope to see you next time. Bye bye.